Hey everybody, welcome back to Algebra 3. Today we're going to be continuing our unit on functions, and we will be doing more algebra with functions. Last time we looked at some graphs, this time we're going to do more algebra. So today we're going to be doing 5 things. We're going to add 2 functions together, we'll subtract 2 functions, we'll multiply, we'll divide. Then after we get done with all of that, we'll do something called a composition of functions. So let's work through some notation that you need to be familiar with. F plus G means that they want to add the functions. You might see it written a little bit differently. Sometimes they write like F, I keep forgetting this. Yeah, F of X, not the best. Let's do this instead. F of X plus G of X for adding. You might see it F plus G or F of X plus G of X. It means the same thing. And the same convention will follow for subtraction, multiplication, and division, and then composition. So we'll work through some of these. You have one section where you have to do add, subtract, multiply, divide, then 2 sections dealing with compositions. So let's get started. All right, in this first example, they want me to subtract, and I can tell they want me to subtract because they want me to find f of x minus g of x. So I am going to color code. I'm going to color code f to be a green function, and then g, I'm going to let it be blue so that I can show you how I'm going to subtract these functions. So if I want to subtract the function f minus g, get blue for g, then I'm going to take the f expression, which is x squared minus 6x minus 27, and then I'm going to subtract the g function, which is x minus 9. But I do need to be careful when I do this, because if I just leave it written just like this, then really I'm not subtracting x minus 9, I'm just subtracting the x. So to show that I want to subtract the entire g function, or g of x, then I need to put this blue part in parentheses, because I want to subtract the entire g function, which means that this negative symbol does need to distribute to both parts. So then I'll write that I'll have x squared minus 6x minus 27 minus x plus 9. And now I can just combine like terms. So x squared, negative 6x minus x is negative 7x. Negative 27 plus 9 is negative, oh dear, I think that's 18. Then I'll enter it and check. So we will check. All right. Now another example that we'll have in here. Next problem. This one is asking me to multiply, and I can tell that's asking me to multiply because I have that closed dot, which, and the circle is closed and small. So I know that this is going to be multiplication. So we're going to multiply this time. Okay, so I'm going to pause and get more space so I can write. So now f is going to be the green function, g is going to be the blue function, and I'm going to multiply f times g, which means I'm going to take this expression for f and multiply it by g. Now these two notations, once again, they mean the same thing. They just look different. F times g of x and f times g without an x mean the same thing. This does not mean multiply by another x. So let's go ahead and copy down f, x squared plus 5x plus 6. Then we're going to multiply it by g, which is x plus 2. Now when I multiply this, I need to distribute. So x squared times the x is x cubed. X squared times 2 is plus 2x squared. 5x, whoa, times x is 5x squared. 5x times 2 is plus 10x. And then finally 6 times x and 6 times 2 would be plus 6x plus 12. So I will combine like terms to get x cubed. 2 and 5 make 7x squared plus 16x plus 12. Then I'll enter this and check. So I entered it, I checked, and I got the correct answer. Now you'll see that if you look at the solution on Delta Math, you'll see they do it a little bit differently where they multiply it. Instead of distributing, the distributing can get a little floppy, so they set up a box and use the box method. So they put the trinomial on top, the x plus 2 on the side, and then they multiply like x squared times x to get x cubed. They multiply in the box, but it does come up with the same solution. So either way is fine. Just use whichever method works best for you. Let's move on to the next one. This time I'm asked to add. The addition ones are probably the easier ones because all you have to do with addition is just add like terms. Whoa, pen's going crazy again. So I'll add like terms. So x squared plus, there's no other x squared to be found, so I'll just have x squared. Then a like term with 3x plus x is plus 4x. And then negative 40 plus 8 is negative 32. So I'll enter this and check. So check. Correct. Yay. All right. And then now we need to look at some division problems. Let me find a division. So here we have a division problem. We need to divide f of x by g of x. So I'm going to let f be blue. I'm going to let g be red. So I want to do f divided by g. So my f function is x squared plus 4x minus 32. So I will just set that up as the numerator. And that's going to be divided by g of x, which is x plus 8. All right, so to divide these, what you'll need to do is you'll need to factor as much as possible. Factor. And divide out common factors. So when I factor the numerator, I know x times x will be x squared. To get 32, I can multiply an 8 times 4. Keep the 8 positive, the 4 negative. Will give you negative 32 when you multiply, and then positive 8x and negative 4x will combine to be positive 4x. And this is still over the denominator x plus 8. So now that I've turned the numerator, I've factored the numerator, now I can divide out the x plus 8 because anything divided by itself is 1, and I'm just left with x minus 4. Checking. All right, so now let's go to the other sections. Now in the composition of functions, composition of function is when you put one function inside the other function. So one notation that you'll see, it looks like Goff, but you would say this out loud, g of f of negative 3. And here is where color coding comes in really, really, really handy. So this time I'm going to let f be blue, and I'm going to let g be red. or pink, whatever color this is. Okay, so g of f of negative 3 means that I'm going to find g of, and then f of negative 3. Okay, so when you work on these, we start from the inside out. So I'm going to start by finding f of negative 3. Now to find f of negative 3, I'm going to go to the f function and replace all the x's with a negative 3. So to do that, I'm going to copy down my f function, but instead of an x, I'll put a parentheses. So instead of 2x squared, I have 2 parentheses squared plus 6 parentheses plus 9. So then I can find f of negative 3 by substituting in a negative 3 for each part. So f of negative 3 is equal to 2 times, now follow order of operations. Negative 3 squared is positive 9. 6 times negative 3 is negative 18 plus 9. 2 times 9 is 18. 18 minus 18 plus 9 is 9. So f of negative 3 is 9. Well, good. I found f of negative 3. So f of negative 3 is the same as 9. So I'm trying to find g of f of negative 3. But since I know that f of negative 3 is the same as 9, I'm going to replace f of negative 3 with 9 now. So instead of g, well, I still have g, but instead of the f of negative 3, I can put the 9 there. So now I need to find g of 9. Well, to find g of 9, I go to the g function, and I'm going to replace the x with a 9. So I start by copying the g function, but instead of x, I put parentheses. And then what goes inside the parentheses? The 9. So 3 times 9 is 27, minus 6. 27 minus 6 is 21. So check. And then you'll have a few more like that. But now let's go back to that last section. Let me erase all this. This last section right here. Now we'll be doing more compositions, but instead of a number, now you have an x. So f of g of x. Or sorry, this is g of f of x. So I'm going to color code again. Let me pause it. Okay, so now I'm going to find g of f of x. I've color coded my g function to be the pink one. Blue is the f function, and I want to find g of f of x. Now, on the last ones, we started from the inside and worked our way out, but that's because we had a number that we could put in place of x. Well, this time we don't have a number, so we're going to start on the outside and work our way in. So I'm going to start with the g function because it's on the outside. So I'm going to start with the g function. I'm going to copy it down, but instead of an x, I'm going to put a parentheses. So this is equal to negative 3 parentheses, make that parentheses pretty big, plus 5. So g was negative 3x plus 5. I wrote down negative 3 parentheses plus 5 because I'm going to replace the x with something. What do I replace the x with? F. I replace the x with the f function. So I'm going to replace it with 3x squared plus x plus 1. And then from here, I just need to simplify. So distribute. Negative 3 times 3x squared would be negative 9x squared. Negative 3 times x is minus 3x. Negative 3 times 1 is minus 3. And then bring down the plus 5. So then, if I combine like terms, just -3 and +5, I have -9x squared minus 3x plus 2. So let's pause and check. All right, checking. Made a mistake. Let's find it. Oh, I found that. I miscopied down the problem. So if you see I have a -1 here, and I wrote a +1. So let's change that to a minus. Change that to a minus, which now means -3 times -1 would be +3. And then +3 plus 5 would be +8 instead. I think that's the only thing that changes. There we go. And then you'll have a few more problems with that. And that should be the section. So good luck on this. If you have any trouble or you need help with anything, as always, please reach out and I will be more than happy to help you, work with you. But have a great day, and I will see you soon.